Welcome back to another tutorial. For this tutorial, we're going to look at a problem involving the Doppler effect. And if you recall, the Doppler effect is an apparent change in frequency due to an object moving. And this object can either be the source or the receiver. And it is, the example I used in class was a race car. So if you're at a racetrack and you hear a race car go past you, you hear the and so it sounds like the frequency is changing, even though the engine of the car is only producing a single sound. But it's because the race car is moving. The same would also be true if we flipped it. If the race car was still, but I was moving very fast towards the race car, I would still hear that change in sound. But we're going to take a look at a problem here. But before that, let's look at our equation. Our equation is right here. We have f prime equals v plus or minus v naught divided by v minus or plus vs all times f naught. And it looks like a complicated equation, but in reality, it's not that bad once we identify these things. So let's take a look. The first thing we have is f naught. This is the changed frequency. So f naught is the original frequency. So f prime is the changed frequency, f naught is the original frequency. So the f naught would be our car engine. That's making one sound. That's like, nah, one sound. The f prime would be the changed frequency that we perceive. All right? Okay, let's take a look at some other variables here. We have v. V is the velocity of a wave. And for our sound waves, velocity of sound in air is 340. And I think most all problems we're going to work with, it is going to be 340. The only exception would be if we had a sound wave in water, then this would not be 340. It would be something different. If we had a sound wave in syrup, it would obviously be different. But in air, it's 340. And we do have this v in two places. Keep in mind, we have it there and we have it there. Okay. We also have v naught. V naught is the velocity of the observer. It is how fast the observer is moving. And you'll see there's a plus or a minus out in front. We're going to keep v naught positive if the observer is moving towards the source. And v naught is going to be negative out in front if the observer is moving away from the source. So you can see right here, we have the positive and the negative. So it's going to be positive once again if the observer is moving towards the source, and negative if the observer is moving away from the source. And our last term is Vs. And Vs is the velocity of the source, and it is negative if the source is moving towards the observer, and it is positive if the source is moving away from the observer. And so you'll notice that these are different. You can see here that for the observer, v naught, it's positive if it's going towards, and for the source, it is negative when it's moving towards. And so to keep that clear, this equation is written in a special way. You may have noticed that right here, it's positive and then negative, and then here, it's negative and then positive. And the reason they do that is so the sign on the top is always moving towards. So it's positive up here because it's moving towards the observer. That positive is on the top. And the negative is on top here because that is moving towards the observer, the source is moving towards the observer. So the top sign is simply moving towards, and the bottom sign, either the negative on the top portion or the positive on the bottom portion, is moving away. That sounds complicated, but I think once we do an example, it'll kind of get clear. So here's our example. We have a bird. It is flying directly towards a stationary bird watcher, and the bird is emitting a frequency of 1250. The bird watcher, however, hears a frequency of 1290 hertz, and we're trying to find the speed of the bird. So let's take a look. And let's write down some numbers that we know. So we have our equation. I see this word here. stationary bird watcher. And so what that tells me is that the observer, because the bird watcher is observing, is 0. He's stationary. He's not moving. This 1250 is the sound the bird is making. So that is the frequency, the original frequency. The frequency the bird is making is 1250 hertz. However, it appears that the changed frequency, that's our f prime, is 1290. Okay. We also know a couple more things. We know what v is. V is the speed of sound in air, because this bird and bird watcher are in air, and we said that was our constant of 340. And the last thing we're trying to find right here, what is the speed of the bird? So the bird is our source. So that is our Vs. And that is our question mark. So armed with this information, we should be able to solve this problem. So let's take a look. So we have f prime. Let's change colors here. F prime equals v. We have a v naught of 0, and our stationary source, not our stationary source, our stationary observer, our bird watcher is stationary. He's not moving towards or away. So this could be a positive or a negative. It really doesn't matter because it's just 0 anyway. Down here we have 340 for our v. The velocity of our source is our question mark. I'm going to leave this at vs. This sign, though, in front of the vs is important because the bird is flying towards the bird watcher. We're down here in this bottom term right here. The towards is the top sign. So that is the negative sign. It needs to be negative for flying towards the bird watcher. And then we have our f naught at the end, which was 1250. All right? And so now we just need to solve this thing for Vs. So it just turns into a straight algebra problem. Let's give us a little more room. There we go. All right, so we have 1290. I'm going to do 340 plus 0. Simplify it a little bit. Take little baby steps. Make sure I don't mess anything up. Okay. I am going to multiply this 1250 into here. So I'm going to pretend it's over 1, and I'm going to multiply the numerators together and the denominators together. And I get 340 times 1250. And I put that in a calculator, and I get 425,000 over 340 minus Vs. So once again, basically I just multiplied this times this. And I multiplied 1 times this, because that was just 1. All right? So now I need to get this out of the bottom. I don't like this variable in the bottom. So to get it out of the bottom, I'm going to multiply both sides times 340 minus Vs. I'm going to do that to this side. And I'm going to do that to this side. And so what that's going to do is that's basically going to cancel that. And so on my right side, I have 425,000. And on my left side, I'm going to distribute. I'm going to multiply both of those. And I get 438,600 minus 1290 Vs. And now I'm going to subtract 438,600 from both sides. That'll go away. I'll get negative 1290 Vs equals negative 13,600. And then you divide both sides by negative both sides by negative 1290. So I'll get rid of that. So I'll have Vs, which is the velocity of the source, which is my bird, which is what I want. That will be 10.5 meters per second. So it's really not too tricky. The hard part, the tricky part, is making sure you get the sign right. Making sure that the sign right here and right here, you're getting those correct. If it's stationary, it doesn't matter. If it's positive or negative, it's just 0. But if the thing is moving towards or away, you need to make sure it's positive or negative. And for the V naught in the numerator, the positive is towards, the negative is away. And for the Vs in the denominator, the negative is towards, if it's flying towards the observer, and the positive if it's flying away from the observer. All right, so thank you very much, and hope you understand these problems. Please feel free to ask me if you have any questions on any of this. Thank you.